In this video, we're going to run Service 2 and look at the performance of the service whilst it is running. Again, we'll use the perf harness command to generate some HTTP traffic to invoke Service 2, and then we'll use the N1 tool to look at system level activity and the ACE web UI to see what the message flow performance looks like. As the perf harness clients start to generate traffic, we can see that the message rate being achieved is substantially different from Service 1, which was running at thousands of messages per second. So why is this flow running so much more slowly? Looking at the N1 screen, that we can see that there is almost no CPU being consumed. But the integration server for PD MISC, which hosts Service 2, is only using a very small amount of CPU, and the message rate is around 7 per second, which is much lower than expected. So what is going on? We've got as far as we can with N1 to debug the problem. We need to see what is happening inside the ACE runtime, and for that, of course, we need the ACE web UI. This is the web UI for the integration server PD MISC, which hosts Service 2. We select the PD demo MISC application, which is where Service 2 is located, and then flow statistics, and we get a summary of all of the message flows running in this integration server. It is Service 2 that we're interested in, so let's click on that. And then the Select Flow Statistics and Layout tab. We can see that the reported message rate of 7 per second corresponds with what we're seeing from perf harness, which is good, as the two different tools see the same behavior. Down below the message flow layout section, we see the data showing the average elapsed, average CPU times, and input messages for the nodes within the message flow. So we want to look for nodes that have a long or high elapsed time, as that will be a very strong pointer to which node or nodes are the cause of the message flow to run slowly. Generally, any elapsed time over 30 to 50 milliseconds for a message flow node is a long time and should be investigated in detail to find out why it is running so slowly. In this case, it's very clear which node is running very slowly. It's Service 2 compute node, which has an elapsed time of around 1.5 seconds, which is really long. Also note that the average CPU time for this same node is only 451 microseconds, so less than half a millisecond of CPU. When we see such a large difference between the elapsed time and CPU time for a flow, then we know there is a delay in processing somewhere. This could be waiting for a response message or a response for a database, for example. We know that we are looking for the source of a delay, not a node that is using a lot of CPU. If it was using a lot of CPU, then both the elapsed time and the CPU time values will both be high, as the elapsed time always includes the CPU time spent in this node. We've got as far as we can in the investigation using the web UI, but it's good because we know which node is the one causing the delay. Next, we need to see the message flow source to see what is running within that node, so let's go to the ACE Toolkit to see the source. Here is the source for Service 2. We click on the node Service 2 Compute, and we can see that the ESQL that runs in that node. There is a sleep for 1.5 seconds, which is why the message flow is running so slowly. It is a contrived example to make a point, but equally it could have been a very slow response from a database query, for example. That is it. We found the cause of the delay. The key stage in this case was finding a node that had a high average elapsed time, but low CPU time in comparison. Then we know that we're looking for a node with a delay or slow response in it. Note also how we had to look at the message flow source to find the cause of the delay, but by using the web UI to look at node elapsed times, we knew exactly which node to look at in the toolkit, which made problem determination much easier and quicker.